This is review meeting 4, and we are group 13. And here are the group members. We have one group member, Lucas, who is going to join us virtually.
So the final design is as shown in the picture, a cooling system which consists of a cooler and a pump that takes in the water from the muscles, cools it down and pours it back into the muscles. A temperature sensor that lets us know what temperature the water is, a pump that is connected to the OD sensor that works accordingly, and a siphon that keeps the water levels equal. A light source that works depending on how much we want the algae to grow, a cooler box that keeps the water insulated, and a microcontroller that controls all the electronics in order for the pump, lights, cooling to work accordingly.
So, are the muscles happy? Yesterday, Tuesday 24th, we moved the muscles from the lab to our system. Today, Wednesday 25th, we've checked on the muscles. The muscles were alive and in the same position as yesterday. The only visual difference between them was the amount of droppings.
To feed the muscles, we attempted to make a mathematical model using the data we got from the experiments. From the experiments, we got values which we used to set up functions for the growth rate and the filtration rate to calculate the algae concentration in each bucket. Then using Python to solve the system of differential equations. This we could unfortunately not get to work. Instead, we've gone with a model where we assume no backflow through the siphoning tube and don't use the formula for the filtration rate. The math shows how we calculated the initial concentration needed to supply the concentration we need in relation to the time and flow rate. We have to get our target amount of algae in the muscle bucket. There are though issues with this method as well. We will only feed them for 1 minute every 33 hours. If we feed them more than that, the concentration of algae will die out, but if we increase the algae concentration, we'll start to overfeed the muscles.
So we did a couple of experiments to figure out our PID system. Here's our first 3 ones. We are only adjusting the KP value, and after these experiments, we figured out that a KP value of 150 was the best system. Here you see our system running for about 2 hours, where we had an overshoot of 7% and a fall time of 1,040 seconds.
And this here is our final web server layout. You can see we plot the temperature, and we have 2 sliders which let us control the set temperature of the PID, and we also have a slider which lets us control the light strength in the algae system. And we also managed to be able to log the data to a TXT file. So in this setup here, we log a data second every 30 seconds, a data point every 30 seconds, and then we can at a later time, extract the data and plot it in Excel.
Okay, so for the OD sensor, we did 2 different methods. We tried to make a flow meter that didn't work that well, but then we tried to use a block light sensor where we stacked 4 tubes to make a larger sample and measure the algae concentration through that. We then calibrated the OD sensor by taking different concentrations, and we then was able to make a negative linear fit.
For innovation and sustainability, we first used a siphon system instead of using 3 pumps, so we only had 2 pumps. We made an insulation system, which we tested to work. We used reusable thermobox to make the insulation system, and we also reused the LED lights. And we also, instead of using an air pump, we used the cooling system to mix the water.
Thank you very much.